Morning, welcome back. Hello. We're pretending to be a streamer again today. We're going to do two sections today. We're going to do 7-1 ratios and proportions, and then we're going to roll immediately on into section 7-2 similar polygons. Let's start with ratios and proportions. These are things that you guys already should have hopefully a little bit of idea on, but let's review. Let's talk about what a ratio is. A ratio is just a comparison using division. It's just divided by. It's a fraction. Normally, you're going to see it written in three different ways. You're going to see it written as, my highlighter being dumb, you're going to see it being written as A to B, like some number, the word two, and then another number. Or you're going to see it as that number and then a colon and then the second number. Or you're going to see it written as a fraction, A over B, A divided by B. In all of these cases, the second number, which is being represented by the letter B, cannot be 0. So we're restricting to no division by 0. So this aspect ratio, this is like the ratio of your screen or the YouTube video that you're watching if you're watching on demand after class. This ratio of 32 to 18 is the same ratio as 16 to 9 because these are equivalent fractions. If you were to divide out those common factors between the 32 and the 18, that common factor being 2, you're gonna get 16 over 9. In the real world, the way ratios are handled is usually when we're talking batting averages, win-loss ratios, if you're in esports or in any kind of sports, the number of boys to girls, the number of girls total, when you're talking segments of population, that kind of thing. And so the way we would parse this particular word problem is it's asking for the batting average. And the batting average is the number of hits that he gets when he's at bat, when he's up to swing, and then the number of times he's up to swing. And so we just find which year that we're talking about. Looks like they want it over the 8-year total. So here it is. I'm looking at the 8-year total. This is the number of times that he was at bat, and in basketball baseball. In baseball, at bat means I got up and I tried to take a swing. And the hits is I actually connected with the ball. It might have been caught and I was out. It might have flown into the stands, and so was something else. I'm not a huge baseball nerd, so help me, leave a comment and tell me what those are called. Maybe it hit my bat and it flew way out of the park and I scored a lot of big points. Anything that makes contact with the ball is called a hit. Now, here's the new thing for most of you guys, because I think that just creating the fractions, easy enough for you. It's these things called extended ratios. It's 3 numbers all in a row. This would be read as 3 to 4 to 5. And with this, we're being asked to find different measurements of things. I'm going to take a moment. I'm going to cover all this up so that way I can kind of half rewrite this. It's asking the ratio of the measures of the angles in a triangle are 3 to 4 to 5. Find the measures of the angles. Let's take a look at this diagram here on the right. Notice how we've got all of the angles with some number and then x. 3 times x, 4 times x, 5 times x. These numbers are the same numbers in my extended ratio of 3, 4, and 5. Since I'm trying to find the measures of these angles, and I know that by the triangle angle sum, I can add up all these angles and get to 180, I'm just going to add up all those pieces. 3x plus 4x plus 5x equals 180. 3 plus 4 plus 5 is 12, pretty sure. The book says that, so I'm going to say that, yeah, it's 12. And then I can divide 180 by 12, and that gives me 15. That's x. I want the measures of each angle. So to find the measure of this angle, I'm going to take 3 and I'm going to multiply by whatever we figured out x was, which in this case was 15. 3 times 15 is 45. Do the same thing at 4x, you get 60. And when you do the same thing to 5x, you get 75. And so here are the measures of each of those angles. You can do the same thing with side lengths, these ratios here, and perimeters. Okay, so I'm going to show you how to do that here. I'm going to write on this little border that I've got. Feel free to write this on the back of your notes or on a scratch sheet of paper. Here's my ratio of the sides. 2, 3, 2, 3. So one side is 2 times some number. The other side is 2 times that same number. And the last side is 3 times that same number. So my ratio 2 to 2 to 3. Now this equals the grand total. I was told the total is the perimeter, and here is my perimeter. So that's what it's going to equal, 392. Here's the equation that you set up, and this then is what I'm solving for x. So 2 plus 2 is 4, plus 3 is 7. And x is whatever I get when I take 392 divided by 7. Someone with a faster calculator than me, please help. I have to find my calculator on the mess that is my desk. What is it? 56? Okay. All right. 56 is x, but I'm not done because I was asked to find the length of the longest side. So of these three, which is the longest? That one, the one with the biggest number. So 3 times 56 is the length of the biggest side. Okay, help me out with 3 times 56. 168. You either use a calculator or you looked at my little answer that I left there for you so that we would know that we were doing it correctly. Okay. So this, I think, is going to be the weirdest for you. I'm going to take a moment and give you some hints. So here, example 1, what we did here, these are your skill practice questions 1 through 5. This example 2 on extended ratios is your skill practice 12 through 15. So feel free to update your notes this way so you know where to come back and look at it. Oh, Miss, what about 6 through 11? 6 through 11 is right in here where we talk about our first big properties of proportions. Proportions are 2 ratios that are equal to each other. So 2 fractions that are equal are called proportions. The number here, the numerator on the left and the denominator on the right are called the extremes. And then the other ones, the denominator on the left and the numerator on the right, are called the means. When you multiply the extremes and you multiply the means, you get what are called cross products. This should be familiar to you from the cross multiply and solve situation. That's where the cross multiplication comes into play. So I'm going to do 3C on my example. I'm going to do that over here in this little space. So I'm going to multiply this extreme and this extreme. So 7 times z plus 4. And that's going to be equal to the means. So those two multiplied together. 9 times z minus 1. I can distribute. Let me go ahead and make my pen a little thinner here. Here we go. So that's 7z. 7 plus 4 is 28. Nine times z is 9z. And 9 times -1 is -9. And now this should be an equation that should be fairly simple to solve. I'm going to subtract 7z from both sides, leaving me with 2z on the right. Gonna add 9 to both sides, giving me 37 on the left, 2z on the right. And then when I divide both sides by 2, I find that my answer is what's listed here in the pink, 37 divided by 2. This is how you're going to do skill practices, questions 6 through 11. Pausing here for a moment to see if you've got any questions. Hit me up in the chat or raise your hand if you're in the live audience, whatever makes you the most comfortable. I couldn't find my new glasses today, so I'm in my old ones. There's spots that are not spots, they're scratches. All right, feels okay? 7-1 is okay? Yes, sir. Yeah, if it's just an x, then this is like a 1x. So this is 1x times -6. And so that becomes -6x equals 4 times 11, 44. Yep. Okay. Question in the chat asking for how to do questions 12 through 15 again. So we're going to come up to here. 12 through 15 are those extended ratios. And those extended ratios, you're basically taking each one of these numbers in the ratio and multiplying them to a variable. So this is going to become 3x. The second one becomes 4x. And the last one becomes 5x. And then you got to figure out what the relationship is. If these are measures of angles in a triangle, then use your triangle angle sum to add them and get to 180. If it's the perimeter, then you're going to add them and set it equal to whatever they told you the perimeter was. Taking a quick look in the skill practice, looks like question 12 is perimeter, 13 is a perimeter, 14 is a perimeter, 15 is a perimeter. So they're all exactly like how we did this guided practice question number 2. If that was your question, please feel free to give me a thumbs up or a thanks or some acknowledgement in the chat or live, depending on who you were in your comfort level. Let me know if that helped you out. Cool. Thank you. Got a public that helped. Awesome. Give me a thumbs up in the Zoom chat if you feel comfortable with 7-1 that you can get through all 15 questions, so we can move on to 7-2. All right, getting some thumbs up in the chat. Cool, I got 2. There's some more. Oh, it's like popcorn, all the thumbs up. All right, let's take a look at 7-2 where we've got similar polygons. Notice the objective. I will solve problems with similar polygons by writing proportions. So we are definitely going to be doing that whole fractions are equal and then cross multiplying and solving. So let's figure out first what similar polygons are and where those proportions, those equal fractions, come into play. Similar polygons are polygons that have the same shape, but not necessarily the same size. We'll know that 2 polygons are similar if and only if the corresponding angles are congruent, but their corresponding side lengths are proportional. And so that is the big difference here. Angles equal measure, side lengths in proportion, which means you can write them as a fraction and you're going to get the same fraction each and every single time, regardless of which side you're working with. Now, remember when we were talking congruent polygons and we said that the order in which you name the corners is important? It's even more important in similar polygons because this tells you which angles are congruent to each other. Since A and W are both the first letters of these polygons' names, it's angles A and W that are congruent. Because B and X come second, angles B and X are the ones that are congruent. And because angles C and Y are third, those are congruent. And D and Z being the last angles, those are congruent. Now take a look at the corresponding sides. Notice how they've matched up the letters on the sides. So AB is the bigger of the two polygons, and the smaller of the two polygons are at the bottom. And they kept that particular setup, the big one being on the top, the smaller one being on the bottom, across all four different fractions to see if those fractions were equal. You don't always have to put the bigger fractions information on top on these fractions. You can definitely choose the smaller one, but whatever order you choose, you have to make sure that you keep it consistent across all the fractions. Otherwise, you could get an incorrect value somewhere and it's going to mess up your corresponding, all your informations. Okay, let's talk about how to write a similarity statement. Similarity statement is like a congruent statement. You're writing that two shapes are similar. And here's the symbol for similar, by the way. It's the congruent symbol without the equals, because not all pieces of these shapes are equal measure, just the angles. So we're going to take the little squiggly tilde and we're going to use that and only that for similar. Here's us listing all the different congruent angles. Here's us figuring out if the sides are in proportion. And then here is our similarity statement. Again, notice the angles that are congruent are written in the same position in the name of the shape. Okay. When you're finding this proportion, when you're looking at this ratio of the side lengths, that's called the scale factor. So let's figure out how they found that the scale factor going from triangle ABC to triangle XYZ is 2. What they did is they looked for corresponding sides. Okay, A is first, X is first. So A and X are corresponding. I'm going to change my color here. And then B is next, Y is next. So B and Y are corresponding. Now I'm going to look at those side lengths. So AB is 6 and XY is 3. Because I want triangle ABC to triangle XYZ, this gets written on top, the first one. And the second one after the word 2, that's what gets written on the bottom. Notice when we go the other way, when we say the scale factor from triangle XYZ to triangle ABC, it's the reciprocal, it's flipped. Because now this triangle's information is on top. They're both the correct scale factor, but it really depends on the order that you're comparing the triangles. Are you comparing big to small or small to big? Questions on this before we move on? So far, so good? This, huh? Okay, and your answer, okay, sorry. This entire page will help you with skill practice questions 1 and 2, because skill practice questions 1 and 2 are asking you to list the scale factor and to write the similarity statement. You are going to have to determine if you're even looking at similar figures. So let's take a moment and let's talk about how we determine if we've got similar figures. The way to determine if we have similar figures is to first check the corresponding angles to make sure that they're equal measure, and then check the corresponding sides to see if you get the same scale factor each and every single time. So for question number 1, you're going to be trying to find a scale factor 3 times, because each of these shapes have 3 sides. So you'll have to set, I guess, AB over DE and figure out what that scale factor is. And then BC over EF, what that scale factor is, and so on. For number 2, you're going to have to find 4 scale factors because these shapes each have 4 sides. Don't forget to explain your reasoning if you find a pair of shapes that are not similar. And your reasoning is this: it's either the angles were not congruent or the sides are not all in proportion. Those are the only 2 reasons that you have. All right, taking a look at questions 3 through 6, we're being told that these polygons are similar and we're being asked to find the value of X. Let's go into here. I'm going to zoom in real tight on the very blurry guided practice 3A and 3B. Notice this right here says, and I'm going to add some text to translate. This says triangle JLM is similar to triangle QST. Just a hair smaller. There we go. So that's what that little phrase of math symbol says. Triangle JLM is similar to triangle QST. All right, since I know they're similar, I know that I've got some proportions happening. So here's J. We're going to do J in orange. And then Q is the one that corresponds with it. So here's Q. We're going to do the next shape, I guess, in green. I feel green right now. Here's L. Here's L. And then over here, S. Here's S. And we're just color coding so we know which angle corresponds to which angle. Third letter is M. Here's M. Third letter on this one is T. There's T. All right, so I'm trying to find for 3A, trying to find the value of X. Here's X living on LM. So I'm going to have LM over, and now I need to find its corresponding partner. So this is green to blue. So I'm going to look on the other triangle, green to blue, and that's S to T. And I'm putting them in the same order because I listed the green corner first, L. I'm going to list the green corner first again. Now I need a proportion, so I'm going to set that equal to another fraction of 2 other sides. And I get to pick what other 2 sides that I want, whichever one is helpful. JL, not helpful because it has a variable in it and I don't yet know what the value of Y is. These are the correct answers just so that you can check your work, but we don't know them yet, so I can't use this information yet. So JL, not the helpful side to use. JM is. So I'm going to go ahead and write JM. And then I'm going to find its corresponding partner. That's QT. Aw, what a cutie. That was such a lame joke this morning. All right, there are my proportions. Now I'm just going to substitute. I'm showing that LM is 6x minus 3. ST is 3. I'm sorry that these came out so blurry. Note to self, don't make them so blurry next time. JM is 4. ST is 3. Okay. And then I can cross multiply and solve. So this is going to be almost exactly like what you did in 7-3. You just have to figure out how you're going to write the equation to start off with. And that's really it for this section. Let me go ahead and finish this out, but while I'm writing away, let me know if you've got any questions. You can hit me up in the chat. Oops, that's supposed to be a 4. I feel like you can solve that equation from there. You'll do the same thing on 3b to get the value of y, and that's exactly what you're doing on skill practice 3 through 6. Last call for questions before I turn off my recording. If you don't have any questions, drop your favorite emoji at me. Question, do the fractions have to be arranged in any order? In terms of which fraction is on the left side of the equation and which fraction is on the right side of the equation, no. In terms of which side you're putting on top and which side you're putting on bottom, again, no. As long as you're consistent across left to right. So in this particular example, I wrote the information for the triangle on the left, this one, the JLM triangle. I wrote that information along the top of the fractions. And then I wrote information on the QST triangle along the bottom. If you wanted to flip it and write the QST triangle on top and the JLM triangle on the bottom, that's fine, as long as you're consistent across the entire equation. Great question, thank you. Yep, perfect. You're welcome. I gotta thank you in the chat. You're very welcome. All right, I don't see any questions, so I'm just taking attendance, but I am going to kill the recording now. Thank you very much for joining in. We're going to do the outro for YouTube real quick. Thanks you so much for watching. Leave a comment if you've got any additional questions, or if you've got a timestamp for me. I greatly appreciate those timestamps. Leave a like and subscribe. I'm trying to push it to 300 subscriptions this school year. I don't know if I can do it, but we'll see. And you have a good one. Thanks.